In this video, we're going to be talking about compound probability. So far, we've talked about simple probability and the difference between theoretical and experimental probability. So a compound event is an event that consists of two or more simple events. So rather than just when we had like the simple event of like probability of rolling a 1 on a 6-sided dice, then now it's going to be like rolling a 1 and then rolling a 2. To determine the probability of compound events, it's going to depend on whether the relationship is independent or dependent. So we're going to take a look at what those two things mean. The first type we're going to talk about are independent events. And when you think about the word independent, it means that you're kind of like on your own, you can do things for yourself, you're not really affected by anybody else. So this is going to be when the outcome of one event does not affect the outcome of another event. Down here we have our rule for the probability of independent events. So once you've decided it's an independent event, you can go ahead and use this formula. To find the probability of A and B, you have to find the probability of A and then multiply it by the probability of B. So for example, we have these two spinners, we're going to spin them both, and the question asks what is the probability that both spinners will show an odd number. So looking at the first spinner, the odd numbers we have are 1 and then 3. So the probability of spinning an odd number on the first spinner is 2 out of 4 possible places that arrow could land. In our second spinner, we have a 1, a 3, a 5, and a 7 as our odd numbers. There are 8 spaces on this spinner though, so there's 4 odd numbers out of 8 possible spaces. So we're going to just multiply the probability of an odd number on the first one times the probability of an odd number on the second. That equals 2 times 4 is 8 on top, and 4 times 8 is 32 on the bottom. But we can simplify this. 8 divided by 8 is 1, and 32 divided by 8 is 4. So the simplest form that we can write that probability in for a fraction is 1/4. Now in the second example, it says a card is drawn from a standard deck of cards and returned. A second card is drawn. What is the probability of drawing a red card and then an ace? So there's some keywords in here. First of all, when it says it's going to be returned, that means the first time you pick it out of the deck, there's 52 cards. You're going to put the card back, and then you still have 52 cards to draw from. So the first event does not affect the second, and that's why these are independent. So to first say we want to find the probability of drawing a red card. Well, half of the deck is red, so 26 possible cards out of the 52 in the deck will figure out are red. That's the probability of red. And then we want to figure out the probability of an ace. There are only 4 aces in a deck, and since we're returning the card, we still have 52 to draw from. So this is going to be how we find our probability. When you multiply 26 times 4 on the top, we get 104. And 52 times 52 is 2,704. And this isn't going to simplify super nicely, so to change it into a decimal, I'm just going to round it to the nearest hundredth. We get 0.04 as our probability of doing both of these things. So next we're going to move on to dependent events. So a dependent event is opposite of an independent event. And the word depend means you're depending on something. So if you're going to depend on something, that means you're relying on it and you're affected by it. When the outcome of one event depends on the outcome of another event, then you have dependent events. So that means that if you're going to say, I want to pick a marble out of a bag, and then I'm not going to replace it, and then I'm going to pick another one out, it's affecting your probability of that second draw because you're not putting the other marble back. So it's dependent on this. Once you decide that events are dependent, you're going to use this formula for probability of A and B. So you first find the probability of A like we're used to, but then we have to find the probability of B after A. So not including A. We have to get rid of the chance that we already pulled A out of there. It's not going to be used in our probability of B for this time. So for this example, it says there are 2 white, 8 red, and 5 blue marbles in a bag, and I have that illustrated down below. Once a marble is selected, it is not replaced. So this not replaced part is that keyword that tells you that we're dealing with dependent events. So that first one you're drawing out of that bag, you have all the marbles to choose from, but once one of them is pulled out, it's not replaced. So you have one less marble in that bag when you go and draw for the second one. So these depend on each other. So to find the probability that 2 red marbles are chosen, we first want to find the probability of a red. To start, we have 2 plus 8 plus 5, 15 total marbles. And to find red out of there, we have 8 that are red. And we're going to say in our second event that we want red, but now we only have, assuming we chose a red one in the first one, we only have 7 red marbles left out of only 14 marbles left in the bag. So that's going to look like we're going to take one of these red marbles out, and now there's only 14 of these left, and only 7 of them are red this time. So that's how we found that probability. We have to then multiply these two events together. When we do that, we get 56 on top over 210. And when we simplify that, it doesn't, we get about 0.26 repeating. So we're just going to approximate it there, and that is our probability. In the second one, we have the probability of a white marble and then a blue marble. So again, let's start with our full bag of marbles. We have a white marble first, and there are 2 white marbles out of the total 15. Say we pulled that white marble out, we got what we wanted. Now we want to pull a blue marble. Well, there's still 5 blue marbles left, but there's only 14 marbles total in the bag. So we have 2 out of 15 for our white probability times 5 out of 14 for our blue probability after the white's been chosen. So we multiply on top and we get 10, and we put that over 210, and you could either write that as a fraction as 1 over 21, or if you want to put it into the calculator and round it to the nearest hundredth, we get about 0.05. Either one would be acceptable there. Okay, so we're going to practice some of these together. It says, determine if the events are independent or dependent, and then find the probability of the compound events. Write your answer in simplest form. So it first says, a coin is tossed and a 6-sided number cube or a die is rolled. Find each probability. So remember, we have 2 different things here. We have a coin, and then we have a die. When you do a coin, or when you flip a coin and then when you roll a die, those are 2 independent events of each other. So this is going to be independent. That means that when I roll the die, it's not going to affect my chances of getting a heads or a tails on the coin when I'm flipping that afterwards. So first we want to do the probability of tails and a 3. So to get the probability of tails, that's tails over 1 over 2. We can get tails or we can get heads, so we have 1 out of 2 chances for that. And then to get a 3 on a 6-sided die, we have a 1 out of 6 chance. So that's 1/2 times 1/6. On top we get 1, and on the bottom we get 12, and that's our simplest form of that fraction. Trying the next one. First we want to find the probability of tails, and then we want to find the probability of getting a number below 3. So tails again, 1/2 chance, and then we figure out that the numbers below 3 are only 1 and 2, so that's 2 possible outcomes out of these 6 total possible outcomes. So on top we get 2, on the bottom we get 12, and this can be simplified. We can divide them both by 2 and get 1 over 6. In number 3, we're finding the probability of heads in an odd number. The probability of heads is 1 over 2. And then to get an odd number, that's 1, 3, or 5. That's 3, and it's out of 6 total. 1 times 3 gets us 3, and 2 times 6 gets us 12. These are both divisible by 3, so we can rewrite this as 1/4. I want you to go ahead and pause the video and try 4, 5, and 6 on your own. Okay, hopefully you paused the video and tried those by yourself. We have the probability of heads and a number greater than 3. That should have been 1/2 times 3 over 6, and that gets us 3 over 12. And again, that simplifies to 1/4. In number 5, the probability of tails and an even number is 1/2 times 3 6 as well. So again, we get 3/12, also equals 1/4. And the last one in number 6, we have heads, which is 1/2, and then a prime number. So our prime numbers are 1, 2, 3, and 5 here. So that's 4 favorable outcomes out of our 6 possible. So that gets us 4 over 12. And this can be simplified to 1/3. They're both divisible by 4. Okay, moving on to the next problem. It says there are 3 yellow, 5 red, 4 blue, and 8 green candies in a bag. Once a candy is selected, it is not replaced. Find each probability. So these keywords, not replaced. Once someone takes Jolly Rancher out of the basket, they're not going to put it back because they want to eat it and it's gone. So here we have dependent events. So say one student comes up and pays me roars for a Jolly Rancher. If there's only one more blue candy left, they can take it, and then when the next student comes up, there's no more blue left. So it's depending on what the first student picks is what the next student has the options of. So the probability of pulling 2 red candies. Well, altogether we have 20 different candies in this bag, and again, it's demonstrated down below. And this time we want to get 2 red candies. To start, there's 5 red out of 20 total pieces. And then we're going to multiply that by our second one. We want to find red again. Well, if I pull red out the first time, I now am down 1 red candy, and my total is now 19. So that second pull, I only have a 4 out of 19 chance of getting a red candy. So on top, I multiply through, and I get 20. And on the bottom, we have 20 times 19, and that equals 380. These numbers are both divisible by 20, and our fraction reduces to 1 over 19. In number 2, we're going to reset our bag of candy. Now we want to find the probability of getting 2 blue candies. So to start, there's only 4 blue candies out of the 20 total candies. After we pull that one, if we get our blue, then there's only going to be 3 possible ways out of 19 pieces of candy. So we're going to do our probability as 4 over 20 times 3 over 19. It's going to get us 12 out of 380. And both of these numbers are divisible by 4. So our fraction ends up being reduced to 3 over 95 in our simplest form there. In number 3, we want to grab a yellow piece and then a blue piece. So when we first have just yellow, there's only 3 out of 20. If I get a yellow, then I'm going to be down to 19 pieces, but I still have 4 blue pieces available. So that's going to mean that we're going to have 3 out of 20 chance of getting a yellow at first, and then we're going to have a 4 out of 19 chance of getting a blue candy second. So that's going to simplify to, again, 12 over 380, which we said was 3 over 95 in simplest form there. Go ahead and pause the video and try 4, 5, and 6 on your own, and then go ahead and press play to check your answers. Okay, hopefully you paused the video and tried these 3 on your own. Let's review them. In this number 4, we want to find the probability of pulling a green and then a red candy. So to start, we have 8 green candies, and there's 20 total. After we pull that, then there will be 5 red candies left, but there's only 19 total candies. So we end up getting 40 out of 380, and these are both divisible by 20, so we get 2 out of 19 as our simplified fraction. In number 5, we want the probability of getting 2 candies as long as they're not green. So the total number of green candies in here is 8, and our total number of candies is 20. So we just have to do 20 minus 8. That's 12 other pieces of candy in there that aren't green. So that means we are going to have the option of pulling 12 out of 20 at first. And then if we remove all of the other candy, we only want to pull the ones that aren't green, and we've already maybe pulled a red. That one's not green. Then we have 11 possible candies left that aren't green, and there's 19 candies still in the bag, because the green ones are still sitting in there. Even though we don't want them, they're still there, so there's a chance we could pull that out. So here we have 12 times 11, and that gets us 132, and then we have over 380. Both of these are divisible by 4, and our simplified fraction is 33 over 95. In the last one, you want the probability of red and then a yellow. So at first, we have 5 red candies, so that's 5 out of 20. And then if we take a red one out, we only have 19 candies left, but there are 3 yellows available, so that's 3 over 19. This becomes 15 over 380. And this fraction is already, actually it is not in simplest form. We can divide these both by 5. And when we divide them both by 5, we get 3 over 76, which is then in simplest form.